Welcome in this session of this tutorial entitled routing. In this lecture, we will study what we call routing topology. And first of all, we talk about what we say dynamic routing. Dynamic routing. What is dynamic routing? And what can happen? First of all, need to remember that as we are talking about routing, it's concerning all about router, which are one of the most important components in networking. These are the characteristics why we are talking about dynamic routing, because directly in this course, we go deep inside the network devices, and that network devices particularly that we select is the one that you call router. And in this session, we will give some property and how the phenomenon that is called routing occur. You need to understand that when we talk about dynamic routing, the routing table are updated regularly according to the state of the network. More complex than static routing and overloading network by exchanging routing information. It allows you to choose the optimal route, and a sequence of packet is no longer ensured in the non-connected mode. So dynamic routing protocol are distance vector routing and link state routing. That's what is used inside of there. Okay, and we have the protocol, the routing protocol. We know in networking that a protocol is the different stage, different order in which an information can proceed. So in this place, we will describe the function and characteristic of the protocol. We configure a devices to use the routing information protocol version 1 and 2. And we will check the routing information protocol if it is working properly. And we must know the difference between the two versions. Okay, let's talk about vector routing distance. In vector routing distance, this is a view or what is about to happen when we are configuring our router using vector routing distance. We have an initial stage, and we have here L1, that means router 1. We have L2, that means router 2. We have L3, that means router number 3. And what is behind is the different routing table that will show how the information will proceed. So in the initial stage, we have destination on L1, on router 1. We have what will come next is next, and we have the cost. In router 2, we have the destination, the next route, and the cost, and the same thing in router 3. Now, how the reception will happen. For the reception to happen, we discover that router 2 will have the cost 0, router 1 will receive, the router 3 the router 2 now will send the information through the interface that know the route where router 3 is found. Let me start back. I said that in router 1, the router 1 must know the route in which it must take to reach router 2. And router 2 must know the route that the information will take, because it took the information from router 1, as you are seeing here. So router 1 know the route to reach router 2, and router 1 here, that information that was coming from router 1, when it reaches router 2 now, router 2 must already be set on the way that it know the way that the information will take to reach router 3. All right. Now, talk about update. This is how update will happen. So the routage table that will occur here will be about the destination, the next path to take, and the course. This is how those updates will happen in the different stage that we are talking about. So in router 1, this is how the update will be set. In router 2, this is how you will set here the destination, the next route that you will take, and the cost. Okay, let's take now, when we say this distance vector routing, in the reception, as we said, this is router 1, router 2, router 3, and how the information will happen. And now this is how those updates will come to pass. And the convergence, this is also how the convergence table will show the information that is passing inside the road. Now, if router 2, let's say that if the way between router 2 and router 3 just got bad, what will happen? If the way between router 2 and router 3 got bad, this is how the update will happen. So router 2 will no more be able to send data to router 3 because it does not know more the way to reach him. In that case, the information will remain inside this other side. And router 1 will send information to router 2. And router 2 now will begin to count an infinitive way because it cannot reach router 3 again. It will count that infinitive way while waiting the problem to be solved. All right. And summary, as we are studying distance vector routing, we have two main problems that occur in this stage. The first one is a loopback appear in the network. All packets to router 3 oscillate between router 1 and router 2 in case that the route got bad, as we were saying. And the algorithm no longer converge. The next exchange route learn from router 2 that henceforth the cost to join router 3 via router 2 is 3. It update is stable to router 3, router 2, and maybe 4. Similarly, router 2 will learn from router 1 that now the cost to join router 3 is 4. This is how the thing will operate. Now, the solution is to forbid a node to signal a destination that is known. The router by which is learned it will use what we call split horizon and limit to the infinite value of the cost is a small value, 16 in routing information protocol if it is greater than convergence. So as soon as infinity is reached. Okay, let's talk about the advantage of that distance vector routing. The advantage will be a simple implementation and maintenance, low resources required. They require little memory to store information. They do not require a powerful CPU either. They usually do not require significant bandwidth to send routing update. However, this can become a problem if you deploy a distance vector protocol in large network. And let's talk also about its disadvantage. The disadvantage is slow convergence. Using periodic update can slow down this convergence. And we have also as disadvantage limited scalability. So it's a slow convergence may limit the size of the network because larger network require more time to propagate routing information. And we have the loop. The routing loop can occur when inconsistent routing tables are not updated due to conversions in the changing network. And now let's talk about uh, routing information protocol. So let's have a view about the history. Historically, routing information protocol has born from an earlier protocol developed by Xerox called Gateway Information Protocol. With the development of Xerox network system, and they subsequently gained popularity as a result of its implementation in Berkeley software distribution. And the several other vendors that create their own routing information protocol implementation with slight difference. So in 1988, recognizing the need to standardize this protocol, Charles Edrick, he wrote in the LFC 10,058 1058, in which he documented the existing protocol and proposed several improvements. So since then, the routing information protocol has been improved with the version 2 in 1934, and the routing information protocol NG was implemented in 1997. All right. And the initially routing information protocol was specified in the consortium that is called LFC 1058. It used the number of drum as a selection of metric for a path. If the number of hop for network is greater than 15, the read protocol cannot provide a route to that network. By default, routing updates are broadcast or multicast every 30 seconds. Okay, encapsulation in that domain, the data portion of read message is encapsulated in UDP segment with the source of destination port number set to 520. The IP header, that is called also antet of IP address, and the data link header at broadcast destination address before sending the message to all configure RIP interface. So this is the presentation of that header of IP, and this is the message format, how the message will look like in the format in the network. So we have the transmission in the routing information protocol version 1. This is how the message format will look like. And the routing information protocol is a class routing protocol. As you may have noted in the previous message format discussion, the routing information protocol version 1 protocol does not send subnet mask information in the update. A router uses the subnet mask configure on a local interface or apply the default subnet mask of the class of the address. Because of this limitation, routing information protocol version 1 network cannot be discontinuous or implement in the VLSM. And this is the pledge of address that can be used concerning the class B, class C, and class A. The monitor of routing interface protocol. In addition of the update timer, the EOS implement 3 additional timers for the routing information protocol. Those are invalid timer, cancellation, and decommissioning. That is why we call the hold down timer. Now, the timer, if not update has been received to refresh an existing route between 180 seconds by default, the router is marked invalid. The router is kept in the routing table until the cancellation timer is expired. And the cancellation timer now, let's talk about it. By default, the undo timer has a value of 240 seconds, in which 60 seconds longer than the timer when the cancel timer display expire. The router is removed from the routing table. The shutdown timer. This timer establishes routing information and can avoid routing loop at the time of convergence of the topology based on new information. Once market is inaccessible, a route must remain out of the service long enough for all routers in the topology to discover the inaccessible network by default. The out of service timer has a value of 180 seconds. What about the update trigger? The trigger update are sent when one of the following events occur. 1. Interface change state. A route does not a route to the inaccessible stage. A route is installed in the routing table, and this is the topology. We have here 3 routers, and those switch that will be we can compare it to station, and the different serial port with the IP address that start from 192.168.3.0/24. So there are different connectivity that will stand inside that network plate, and we have here the periphery as router 1, router 2, router 3 with the different interface with the fast internet interface and serial interface and the IP address that is allowed to them. I have also the subnet max 255.0. Okay, now router configuration in RIP version 1. RIP is enabled by using the router RIP global configuration command, the network command, and enable RIP on all interfaces that belong to a specific network. Associate interface now send the receive router information protocol update. Announce the network specified in routing information protocol routing update sent to other router every 30 seconds. Syntax is router config network directly connected classful network address. Note, if you enter a subnet address, the US automatically convert it to a network address by class. For example, if you enter the command network 192.168.1.32, the router will convert it to a network, and we will have 192.168.1.0. The command to solve in case that there is a damage. In case there is a damage, these 3 commands are represented in order in which they are suggested to be used to verify and troubleshoot a routing protocol configuration. To check and troubleshoot the routing, we use the command show IP route and show IP protocol. If you can isolate the problem using these 2 commands, use debug IP RIP to see exactly what is going on. Remember that before configuring a router, it must be in static or dynamic. We must make sure that necessary interfaces are active by using the show IP interface and those brief commands. Analyzing a row in the routing table. For example, if you want to analyze a row in the routing table, you will use this router that have this IP address mentioning here, and you have is connected via this other address and this serial port. The list of routers indicated by the letter L is a quick way to check that the routing information protocol is running on this router. If the RIP protocol is not partially configured, no RIP rule will be listed. The remote network address and the subnet mask are then listed. The administrative distance value will be 120 for the RIP protocol, and the distance of the network will be 2 jump, as shown in the square bracket. No, so the IP address of the next leg of the advertiser router is indicated in router 2, and the address that is mentioned as is the number of seconds since the last update has been made. In this case, we took something like this time 23 seconds. And finally, the output interface will be used by this router for the traffic destiny to remote network is indicated in serial. Administrative distance. The administrative distance is the correspond to the reliability of the source route. The default administrative distance in RIP is 120. It's an example, as you can see in the diagram, compared to other IGP protocol that's called an gateway protocol and the open shortest path. First is they prefer to use ESIS and RIP protocol. So this is some root source, and these are the administrative distance shown in the diagram here. And the verification protocol in RIP. If a network does not appear in the routing table, check the routing configuration using the show IP protocol command. This displays the routing protocol currently configured in the router. This information can be used to check most routing information protocols sitting on confirming the following. The RIP protocol is configured, the appropriate interface send and receive RIP update. The router announce the appropriate network. RIP neighbor send update. Most RIP configuration errors are due to an incorrect or missing network configuration statement or to configuration of discontinuous subnet in class environment. The debug of IP command is used to identify issues that affect RIP update. This command display RIP routing update when they are sent and received. And you have also the passive interface. Is sending unnecessary update on a local network affect the 3-tier network, and transporting unnecessary update waste boundaries since RIP update are broadcast. Switches will transfer update from all ports. All devices on the LAN must proceed the update to transport layer, where the receiving device will ignore the update. Announcing update on the broadcast network is security risk. RIP update can be intercepted by packet analysis. Software routing update can be modified and returned to the router with false metric that corrupt the routing table and cause incorrect routing of traffic. We can run the passive interface command in router configuration mode to stop sending routing update through the specified interface. And this command is router config passive interface type interface numero interface, so the number of the interface. And this is the network topology that can be also apply it when you want to configure it. This is an example. And the devices router, there are some router that is at the periphery. Yes, routing interface protocol is a class-based routing protocol that automatically summarizes class network at edge of primary network. In the figure, you can see that the router 2 has interface in the several main network per class. This makes router to an edge router in the RIP protocol. The serial 000 and fast Ethernet 00 interface of the router of R2 router are both within 172.13.0.0 network edge. The serial 001 interface is inside the 192 and 168.0.4.0 network edge because interface router summarize IP subnet from the primary network to another update for the 172.13.1.0 172.13.1.0 and 172.13.3.0 network automatically summarized in 00. So the network part will remain 172 and 13. When sending them via the interface serial 001 of the router 2, and the example will be seen in this picture as you are seeing here, what we are talking about those peripheral router, those devices. Update processing rule. The following rule govern the RIP version 1 update. If a routing update and the interface on which is received belong to the same main network, the subnet mask of the interface is applied to the network in the routing update. If the routing update and the interface on which is received belong to two different major network, the network class subnet mask is applied to that network in the routing update. So, update from router 1 to router 2. How does router 2 know that this subnet has a subnet mark 24? He knows it because router 2 receives this information on the information belonging to the same class network as that of the incoming update. The IP address of the serial 00 interface through which router 2 received the message was 172.13.1.0 in one up is 172.13.2.2, and the subnet max 255.255.255.0 is used, and the router 2 is own subnet max, so that router 2 is own subnet max on its interface, which is applied to its subnet and all other address in the subnet that is received on its interface. And the subnet 172.13.1.0 has been added to the routing table. But caution, router running in RIP version 1 must use the same subnet mask for all subnet with this same network per class. And the advantage of the automatic route summary. Routing updates send and receive are smaller, allowing this bandwidth for routing update between router 2 and router 3. Router 3 has the single route for 172.13.0.0 network regardless of the number of subnets or how it is subdivided, using the single route speed or up to the search process in the routing table. And this is the topological network that can be represented. And this is the default route that can be applied. And the default route, what happened there, we know that we disable the routing information protocol routing for the address 192 and 168.4.0 on the network that is taken by router 2. And we configure router 2 with the default static route to send the default traffic to router 3. This is the command that we will use. And here we disable RIP routing, and we configure router 2 with the default static route to send the default traffic to router 3. And right now we have the command that will be used for it. And we check the routing table for both router. And now the propagation of the default route in RIP version 1. To provide internet connectivity for all network in the RIP routing domain, the default static route must be advised to other router that use router protocol. With many routing protocol include RIP, you can use the default information originate command in router configuration mode, and you use this command. And the routing table, you can see the presence of potential default route that is indicated by the code R. And like RIP version 1, if you want to talk about RIP version 2 now, we know that RIP version 2 is a distance vector routing protocol. Both versions of RIP have the following feature and limitation: shut down another timer to try to avoid routing loops, cutting horizon without reverse poisoning of the same purpose, updating trigger when the topology change for faster convergence, maximum number of jump limited to 15. A hop count of 16 indicate a inaccessible network. Since this is a classless routing protocol, the RIP version 2 include the subnet masks at the network address of the routing update, like other classless routing protocol. RIP version 2 support CDR and VSR and continuous network network. And this is the message format in RIP version 2. This is how we can compare it. This is the presentation of the RIP in version 2. And this is the presentation of those versions, what is really different between RIP version 1 and RIP version 2. As you are seeing here in version 2, you have those etiquette rule, those network marks, the next rule, and the metric. This is the different element that are showing here. As you see, it's underlying, they are lighting to help you to understand that there are so many difference between those different versions of routing information protocol. All right, this is the end of our presentation concerning those automatic summary. We will continue the next time to present, but the next time we talk about the open shorted path first, the protocol that is concerning open shorted path first. But in summary, we need to see for the automatic route, we will use those commands that is presented here. For the static route and null interface, we use also this stage to configure it. So I will be glad to see you the next time. Thank you for watching this and to give us the possibility to share this session with you. Thank you very much.